we discussed that if we will connect a battery like this, if we will connect a battery like this, then this battery will provide the continuous potential difference. This battery will provide the continuous potential difference, and due to that there will be continuous electric current, continuous flow of electric current. And if there is a continuous flow of electric current, so the electrical appliances can be run through that. Here you can take the example of the light bulb. For the continuous glow of this light bulb, the current should flow continuously through this bulb. And when there will be the continuous flow of the current, when you will connect a battery, this battery will give the potential difference between the two ends of the wire, and due to that there will be the continuous flow of current, and there will be the continuous glow of the light bulb. Now I will talk about the direction of the electric current. Direction of electric current. Hello, Martin. Martin, are you getting my voice? Hamna and Eman, please write in the chat box if you are not, if your microphone is not working. Martin, Eman, Hamna. Okay, fine. So, okay. After that, we will discuss the what is the direction of the electric current. Means how we will define the direction of the electric current. And what is electric current? Electric current, I told you, is the flow of electric charge. And charge is of two types: positive charge or negative charge. So current is a flow of positive charge or a negative charge. Okay, we will discuss that. So actually, long time ago, uh, we know only there are two types of charges. Okay, long time ago, we have that information that there are two types of charges. One is positive charge, another is negative charge. But at that time, na, electron was not discovered at that time. Electron was not discovered at that time. So now we know the main reason of the flow of current is free electrons. Now we know that why the current flows in a conductor, due to the free electrons, means due to electrons. But at that time electron was not discovered. At that time electron was not discovered, and they know that there are two types of charges: positive and negative charges. Positive and negative charges. So they assume that the current is a flow of positive charge. Okay, the direction of the current is a flow of the positive charge. Or you can say the current will flow from the positive terminal of a cell to the negative terminal. This was the conventional direction of the current. Okay, so the direction of the current, you can see here, the conventional means earlier they assumed that the direction of the electric current is from positive terminal of a cell to the negative terminal of a cell through the outer circuit. Now we know that the current, in actual, what is the reason of the electric current? Free electrons in a wire. An electron moves from negative terminal to the positive terminal because electrons are negatively charged. So if the electrons are negatively charged, so they will move from negative to positive. But the direction of the current was assumed from positive terminal to the negative terminal. Why? Because earlier we don't know there was electron or not. So you have to remember this point. The conventional direction of the current is from positive terminal of a cell to the negative terminal of a cell through the outer circuit. Through the outer circuit. Okay. So direction of the current, you will say, is from positive terminal of a cell to the negative terminal of a cell. Or instead of cell, you can say positive terminal of a cell to the negative terminal. You can say positive terminal of a battery to the negative terminal of a battery. Now we will discuss in a wire. We have seen we have wires. So we know that in wires there are electrons and there are free electrons also. Okay. In conductors there are free electrons. Now if you have not connected that wire with any electrical source, so you have seen that there will be no current in that wire, but there will be free electrons. So for the flow of current in a wire, you should connect that wire with some electrical input. Okay. So now I will show you the two conditions when a wire is connected to some battery. What is battery or cell? Battery or cell is some source of electrical energy. Okay. So first condition, we will see that what is happening inside the wire to the free electron when the wire is not connected to any cell or a battery, and we will see the condition of a wire when we have connected the wire with some cell or battery. You can see here. So this is a zoomed view of a wire. This is a zoomed view of a wire. We know that in a wire there are free electrons. So these are the free electrons inside the wire. And this is the condition when no cell or a battery is connected to this wire. Okay. This is a portion of a wire I have taken and I have zoomed in and I found that there are free electrons inside the wire, and this is a metal wire, so we know that in metal there are free electrons. So these are the free electrons, and these arrows are representing this arrow, this arrow, this arrow, this arrow, this arrow. These are representing the direction of motion of electrons. So you can see here the electrons are moving in randomly in all the directions. Here the electrons are moving randomly in all the directions. Okay. So due to this, there will be no current generated. Due to this, there will be no current generated. This theory you will study in more detail when you will have physics in your 12th class. Okay. So here we will only discuss the basic portion. Okay. So why there is no current in this wire? Because the electrons are moving randomly in all the directions, and due to that the average velocity of electron basically becomes zero and there is no net current generated in the wire. Now this wire, if you have taken this wire and you have connected this wire with some battery or cell, now this wire is connected to some battery or a cell. So what is the work of the cell? This cell will provide a potential difference, continuous potential difference. Now what happens now when the cell or a battery is connected, an electric force is applied. Okay, an electric force is applied on electron to move from the negative terminal to the positive terminal in a regular order. Now you can see when you have connected the cell or a battery, these electrons are moving in the same direction from negative terminal. Okay, from the negative end of the wire to the positive end of the wire, the electrons are moving right now. So if the electrons are moving from negative end to the positive end, okay, so basically you can say that this is the direction of the flow of electron. And what I told you about the direction of the current. Direction of the current is from positive terminal of a cell or a battery to a negative terminal of a cell or a battery. So here you can see the electrons are flowing from negative to positive, but the direction of the current will be taken as from positive to negative. Means the direction of the current you will take in this direction. Means to the opposite direction of the flow of electron, you will take the direction of the conventional current. Okay, so you can add one point here. The direction of electric current, the direction of electric current, electric current is taken as opposite to the flow of, opposite to the direction of flow of electron, opposite to the direction of flow of electron. So these are some points that you have to remember. So what you have seen here, earlier when the wire is not connected with battery, electrons are moving randomly in all the direction. Due to that, there is no net current in the wire. But when you have connected this wire with a cell or a battery, an electric force is applied on the electron, so that the electron is moving from negative terminal to the positive terminal, and due to the flow of electron, there will be the current. Okay, and direction of the current you will take the opposite to the flow of the electron. Okay, please write down, all of you. Hamna, Martin, Eman, write down. Martin, understanding?
Yes, sir.
Ask me to scroll down when completed. Okay.
Third answer.
Okay. Completed Hamna and Aman? Okay. I think completed. Now write down this. Martin completed. Turn.
No, sir, I'm doing.
Okay. Hamna completed. Hello, Abdullah. Abdullah, are you getting my voice? Hamna completed. Martin, is my voice okay na?
Yes, sir.
Okay, so now I think completed. So we will discuss now Ohm's law. We will discuss Ohm's law. So Martin, can you tell me what is Ohm's law? Very famous.
Yeah.
Tell me.
Potential difference we across the ends of a given metallic wire.
No, no, no. Actually, this is incomplete statement. We cannot say that Ohm's law is potential difference is directly proportional to the current. Always. Not always the potential difference is directly proportional to the current. There are some devices that those devices do not follow Ohm's law. Those devices you will study later, maybe non-ohmic devices like transistor, diode. I'm not going in detail, but Ohm's law is not that. Basically, what is Ohm's law? You have to add one point at constant temperature. Okay, at constant temperature. If the temperature of the wire is not changing, okay, if the temperature of the wire is not changing, then only you can say the potential difference across the ends of the wire is directly proportional to the current flowing in the wire. That is Ohm's law. That is Ohm's law. You can see here. Okay, so always remember you have to add this point at constant temperature. Otherwise, this will be no longer Ohm's law. This will be some other thing. This will be a simple statement. So what is Ohm's law? At constant temperature, the current flowing through a conductor or wire is directly proportional to the potential difference across its end. So what is the meaning of the directly proportional? Like this. Current is directly proportional to the potential difference, or you can say potential difference is directly proportional to current. Both are same thing. So current flowing in a wire, what is I? I told you I will represent the current with capital I. And I told you that I will represent the potential difference with capital V. So current flowing in the wire, what is I? I is the current flowing in the wire is directly proportional to the potential difference only and only at constant temperature. If the temperature of the wire will change, then this relation will not valid. And what is the meaning of this directly proportional? Directly proportional means if you will increase the potential difference across the ends of the wire, then the current flowing in the wire will increase. At the same time, you can say if you will decrease the potential difference across the ends of the wire, then the current flowing in the wire will decrease. Okay, so this current is directly proportional to V. You can write this thing like this also. Okay, so you can write potential difference is directly proportional to the current. Potential difference is directly proportional to the current. Now this proportionality sign when you will remove, no? So here will be the equal to sign and here will be one constant term. Here will be one equal to sign and here will be one constant term, and this is I, and this constant term is known as is the resistance of the conductor. This constant term is what? Is resistance of conductor. Okay, resistance of conductor, and this is constant. And what is V? Potential difference across the ends of wire. Okay, across the ends of a wire or conductor. So you can write potential difference across ends of conductor. You can say ends of conductor, or what is the current? I is the current flowing in conductor. Current flowing in conductor. Current flowing in conductor. Okay, and R is the resistance of the conductor. We will discuss in detail about the resistance. And finally, you have to remember V is equal to IR. V is equal to IR. This relation you will get from the Ohm's law. We are getting this relation from the Ohm's law, and this relation is valid only when there is a constant temperature. So generally we see that the temperature of the wires remain constant. For example, you can take the wire of this mouse. So right now the temperature of this mouse is working. You can see mouse is working. My mouse is working in the working condition, but the temperature of this wire is increasing or decreasing or is same all the time. Right now, the temperature of this wire is same. So that is why most of the devices follow Ohm's law. Okay. And if you want to find the current, then you can write I is equal to V by R. I is equal to V by R, you can write. Write down, all of you. Completed. Hamna, Martin, Abdullah, Eman.
Yes, sir.
Okay. Martin, are you writing or completed?
Completed, sir.
Okay. So write down this also. Then we will move to the numericals. You have to remember this relation. V is equal to IR. Potential difference, current, and resistance. Potential difference, current, and resistance. Okay. So just wait 1 minute. Okay, so see this question. Potential difference between 2 points of a wire carrying 2 ampere current is 0.1 volt. So you can take a wire. This is a wire, suppose. So they are saying that suppose this is point A of the wire and this is point B of the wire. Okay. There are 2 points of the wire. They are saying the potential difference between these 2 points of the wire, and in this wire there is a current of 2 ampere. Okay. There is a current of 2 ampere is there and the potential difference is 0.1 volt. Potential difference means it is given V is equal to 0.1 volt between the ends of the wire. Calculate the resistance between these points. Between these 2 points of the wire, this is a wire. You have to calculate the resistance. Apply V is equal to IR.
Sir,
V is equal
resistance is equals to 1 by 20.
Okay. V is equal to IR. So from here you will get resistance. R is equal to V by R. V upon I. So V is right answer. V is 0.1 and I is 2. So when you will remove this point, you will get 1 divided by 20 ohm. Remember the unit of the resistance is ohm, OHM ohm. And this OHM ohm is also represented by this symbol. Okay, and 1 by 20 is 0.05 also. You can write in that form also. Okay. Now another question. They are saying an electric iron draws a current of 3.4 ampere from the 220 volt supply line. So 220 volt supply line, and they are saying what current will the electric iron draw when connected to a 110 volt supply line. So now here now you have to see what is the condition. There is an electric iron in your home also. There are electric irons. Suppose you have connected that electric iron, okay, and the electricity is coming in the switchboard, and you have connected that electric iron, and from that switchboard you are getting the potential difference of 220 volt, and the current flowing in the electric iron is 3.4 ampere initially. After that, what you have done, you have changed the switchboard. I am not saying you have changed the switchboard. I am just giving the example for solving this question. After that, what happens? You have changed the switchboard, and from that switchboard, you are getting a potential difference of this, and current of means you have to find the current. Understanding now what I am saying? So here you have to assume one point. Electric iron. So basically there are alloys in that. So we will assume here the resistance of the electric iron will not change. If you are first connecting with 220 volt supply, then you are connecting that iron with 110 volt supply. Resistance will not change. Okay, resistance will not change. So this concept we will use. Resistance will not change. Resistance and resistance will be cancelled out, and we will get the current. See, in first condition, what you have? You have suppose the current I1. I1 is the current. I1 means initially what is the current in the iron? I1 is 3.4 ampere. And what is V1? V1 is 220 volt. Okay, 220 volt. Okay. You can do one more thing. You can apply here V is equal to IR. From this, you will get the resistance of the electrical iron. Okay. So apply V is equal to IR. Now what is V? 220 volt. What is I? 3.4 ampere. And resistance of the electrical iron is R. Suppose R is the resistance of electrical iron. So from here you will get 220 divided by 3.4 ohm. This will be the resistance of the electrical iron you will get. Now see, in the second case you are connecting the electrical iron, means in the second case the potential difference is 110 volt. You can see here what current will this electrical iron draw when connected to. Now this electrical iron is connected to 110 volt supply line, means the potential difference in the electrical iron will be 110 volt. Okay, and current you have to find. This is suppose V2, second time. I2 you want to find. Now resistance of the electrical iron will be same, so resistance will be resistance, that will be 220 divided by 3.4 ohm. Now V is equal, apply V is equal to IR, you will get I2. V is equal to IR. So V will be 110 this time. What will be the current? You have to find the current. Resistance you have 220 divided by 3.4. 220 divided by 3.4. Now from this you will get I2. Very easy. I2 you will get, now cross multiply this 110, 3.4, 110 multiplied by 3.4 and divided by 220, and this will be cancel out. Okay, 110 multiplied by 2 is 220 and 3.4 divided by 2 is 1.7 ampere current will be there. So the current in the electrical iron, when the electrical iron is connected to a 110 volt supply line, will be 1.7 ampere, and note down. Completed?
Yes, sir.
Okay. So write down this one. Martin completed. Hamna and Aman completed.
Yes,
Martin, are you writing or completed?
Completed.
You're writing.
No, I'm finished.
Okay. I think completed now. Okay. So now see this. This is the electrical circuit. This is the electrical circuit. You can see in electrical circuit. First is this. You can say this is the wire. This is the wire. Electric bulb. And this is a switch. And this is a cell or a battery. We have connected the cell or a battery so that there should be a constant potential difference and there should be a constant current so that our devices run smoothly. So this is the first condition. Here the switch is closed. This switch is closed. Closed switch means, always remember, if the switch will be closed, then current will flow. You can see this is a closed condition. Here you can see, and the current will flow continuously. Now see here, this is the condition where the switch is open, and if the switch is open means that you have disconnected the wire from the battery indirectly, you can say. And if you have disconnected, there will be no potential difference, so there will be no current. So basically I want to tell you what is the electrical circuit. Basically electrical circuit is a combination of the electrical wires, cell or a battery can be there, electrical switches, electrical bulb, and there are different types of electrical circuit also. If you are using your laptop right now, This is also the electric circuit. Okay. So there is no need to draw this. Okay. For example, if this electrical circuit you have to study, for example, if you want to study this electrical circuit, okay, you want to see when the current is high, when the current is low. In that case, you have to draw this circuit on paper, or you have to show this circuit somewhere. So now at that time, you will not draw the diagram of this cell there exactly like this. You will not draw the switch like this. You will not draw the electric bulb or any other electrical appliances in your circuit diagram. So what we have done, we have given some of the symbols, okay, to the cell, switch, wire, resistance, variable resistance. Those symbols, at least uh, 5 or 6 you should learn, okay, because that will be required when we will solve questions. So these are some symbols, okay. So this is a symbol of a cell, okay. This is a symbol of a cell. I already drawn here when we were discussing, okay. Here I have drawn, you can see cell, symbol of a cell, okay. So we will not draw the cell here, we will only draw the symbol, okay. So now you can see this cell, and this is a symbol of the battery. Basically, what is battery? Battery is a combination of multiple cells. More than 1 or 2 cell, you can say is a battery. So the symbol of the battery is like this. This is a symbol of connecting wire, is simply like straight line. This is a wire joint. We join na wire, one wire to the another. So this is a wire joint symbol. Okay, and this is a wire crossing without contact. So what is the meaning of this? If suppose I am having this wire and I am having this another wire, okay, if these two wires are not in contact, they are crossing, just crossing each other, so that symbol is here. This is the symbol. This is the symbol of the resistance. Okay, you can see this is zigzag path. Basically, resistance is the hindrance in the path of the current. So that is why the symbol is denoted like this. Resistance, no? More will be the resistance of the wire, less will be the current. We will see. This is a symbol of the variable resistance. Basically, there will be one experiment in your lab based on the Ohm's law. So for different potential difference, you will have different values of current. And on the graph paper, there you will draw the graph and you will get a straight line. That you will do with the help of the variable resistance. I don't know whether you have seen variable resistance in your lab or not. So this is the symbol of variable resistance, or you can represent the variable resistance like this also. You will understand properly why this symbol is like this when you will see the variable resistance. And variable resistance is also known as rheostat. Rheostat, okay. This is ammeter, already discussed. Ammeter. What is the use of ammeter? Hmm?
Used to measure the
Hmm.
current.
Hmm. Yeah, you are right. And in series or in parallel, we connect ammeter
Series.
in series, yeah. And voltmeter also, to measure the potential difference between any 2 points of the wire. Now there is, and voltmeter is always connected in parallel. Now there is one more thing, galvanometer. Basically, galvanometer is used to measure very small currents. Basically, it is used to detect the current, you can say, not to measure the current. So this is a symbol of galvanometer. This is G and this is circle. This is a symbol of switch or key, you can say. This or either you can use this symbol. Okay, this is an open switch. Open. Open switch, I told you that there will be no current. Closed switch means joint is there, means there will be current in the wire and devices will run. Electric bulb, symbol of the electric bulb is this or this. So I will recommend you to uh, draw the symbol like this. Okay, I have already drawn the symbol here, I think. Electric bulb. Okay, so copy these symbols. Believe me, these symbols are very important for exam point of view also, because when you will solve the circuit, these symbols will be there. With the help of these symbol, you will understand whether this is switch, whether this is ammeter, whether this is battery, or this is a resistance or whatever. Copy this. Or if you want, you can take the screenshot also. If you want to take the screenshot, then you can take the screenshot also. Martin, Hamna, Eman, all of you.
Yeah, doing so.
Okay, write down, no problem.
Yeah, done so.
Okay, so all of you, uh, revise your notes properly, revise